Yes, I hear you.
Okay. All right. So. Okay, so I found out that root user, once you get the sudo access, that user will have a root access too. So if you want to limit somebody's access to root, then there's a third-party application that is being used. So that is beyond our this class. So we'll see. We'll work on permissions. So let's see here. So let me save and exit here or quit. Okay, so I'll start off on permissions here. Okay, so let's work. Let me see here. Root. So what I'm going to do is I'm going to create a file, touch file 1. Okay, and if I do ls-l, you see so many attributes in here. So let's talk about this. So let's see here. Okay, so what I have here is, let's start off with file permission. Okay, so let me do this here. So here, when I do ls-l, let's copy this here. So our focus is this part here. So let's focus on this here. What does this actually means? Okay, so I'm gonna copy this. Let's see here. Let me copy this. Okay, so now we're gonna go from right to left here. So in here you see 1, 2, 3, 4, 5, 6, 7, 8, 9. We have about 9 fields in here, right? So I'll come to the 10th field in a minute. So we are dealing with this many fields here. So we have this part here, this part, and then this part here. Okay, so on the color here, so the very first one, hyphen. Okay, if this is hyphen, right? So what is this means? This means it's a file. Hyphen. Hyphen is not part of permission. But indicates it's a file. If it's a hyphen, then looking at just the hyphen, you could tell this is a file. Okay, and then later on, if this file is a directory, then the hyphen will become D as in dog. Okay, so but right now let's focus on only the file information here. So what I have here is the yellow part is for the owner's permission. The other part, orange part, is for user's permission. Okay, I'm sorry. The other is group permission here, the orange part, and then the red part is for others. Okay, so let me. How many we have? 9 here, right? Yeah. Okay, so first part is users. User, and it is noted by U, a lowercase u, and then it's also known as owner of the file. Okay, and then the second part is group, and the letter which is associated with this is G. Okay, and others, that means if they are not part of a group and if they're not users, then others. It is notated by O. Okay, and in here we have 3 spaces here, right? R, W, and then the space here. So each space represents something here. So the very first octet represents read, and then write, and execute. And it repeats in here in the group too. Read, write, execute, read, write, execute. Okay. And then let's see RW. I'm going to put down RW here. Lowercase r, lowercase w, and then this has a space in there. Okay, and then this one is R, space, blank, and then blank, and then others, read, blank, and blank. So what does this means is, so this file, the owner of this file here, he has read and write permissions. Okay, owner. When you create a file, you become an owner. He has a read and write permissions here. He does not have execute permissions. By default, there are no files that will have execute permissions here, okay? Same thing with the group here. If you are a part of a group, you could only read. You cannot write to the file. You cannot execute the file. Okay, and I'll explain you what execute means a little bit later. But just understand, executing the file, that means you're like, if it's a script file, you're executing the file. And then others have the same permission too. He could only read, he cannot write or execute it. Okay, so all these things have a number associated with it. A read number is 4. Okay, if you're giving the permission 4, that means you're giving a permission read. Okay, and then the number associated with write is 2. And number associated with execute is 1. Okay, same thing here. 4, 2, 1. 4, 2, 1. Okay, so I'm going to put it down here. Read equals to 4. Write equals to 2. Execute equal to 1. Okay, is that clear so far?
Yeah.
So when it says read means you could read the file. Okay, write means write into the file.
Does write also mean like you could edit it?
Yes.
Okay.
So write means you don't you have edit permissions. Okay, that's a good question here. Edit permissions. So read permissions. And execute means you could execute the commands or you could execute the file. This is for script. Script file. This is for script file. You could execute the file. Execute the file. Also deleting the file. Deleting the file or folder. All these things comes under execution. Okay, deleting is execution. Running the file, like executing a file, if it's a script file, is also a execute permissions. Okay. So now let's focus here. So over here, there is a number associated with this here, right? So let's see what is this number, what is the number associated with this file here, the permission file. So let's see here. I'm going to say number value of permission for file 1. Actually, let me just create a touch file 1, touch file 1, so that we're not just dealing with okay, so essentially it's the same thing. So what is the number associated with this permissions for this file here? Can you take a wild guess? So the permissions we have here for this file is read, write, execute, right? So looking at here, I'm going to put it here. So let me make a little table here. Okay, the first part is for the owners, right? First part is for the owners, which is user, group, and the third one is for others. So in here we have read write. Read write, and hyphen means meaningless. Hyphen doesn't have any. That means that permission is not available. And this is read hyphen hyphen. And then the others is read read hyphen hyphen. Okay, so what would be the number here? For read write, if you do the math here, addition, what would be the number for read write?
6.
Yeah, this is 6. What about write? Or what about group?
4.
4, good. And what about read here? Others is 4 also. So the default, most of the time, this is the permission here. We're not doing anything. And then the system automatically assigned the permission 644. So the final permission number is the permission number for file 1 is 644. Okay, 644 is also default permission in Linux system. Default permission for files in Linux system. Okay, so if I create like 100 file here, touch file, and then I'm going to create 10 files here. So what happens here is by default, all the file permissions are going to be the same. Okay, so there is a default value set somewhere. I'll show you in a minute that it's drawing that from there. So I'm going to say rf -rm and asterisk. What am I doing here? Yeah. So I have only one file left. So I'm going to clear this. I do ls-l. So default permission is coming from some other place here. So, but we're going to focus on changing the permissions here. So what I want to do is I want to modify the permissions here, right? So as a Linux admin, you will be doing this a lot, day in and day out. Modify the permission. Suppose I have this user here. I want to give these two user. So I want to give group also read write permission, and this one also read write permission. So how would I do that? I could use the numbers, right? So I'm going to give chmod Okay, so this is the new command for you guys. Chmod. Chmod stands for change. Chmod is change modification. Change modify or whatever. Let's see here. Okay, change mod bits. Chmod. What it's called? What is the official name? Change file mode. Okay, change file mode. That's what it's called. Chmod. Okay, so I'm gonna type chmod. So I'm gonna give this part and this part the same permission as first part users. So what is the number I would use with that? So 644 is the current permissions here. This is 6, this part is 6, this part is 4, and this part is 4. So I want to give this permission to these guys here. So what I'm going to do is, I know the first part I want to keep the same 6. So what would be the next one? It would be 6 also, 6. Chmod 666 and then the file name. So what will happen is, so where is this 666 coming from? I want to give the same permission here, right? So this one, the number value is 6. So if I want to add right in here, I would do 6 because it's 6 is part of, 6 in part is 2, 4 plus 2 is 6. So 4 is associated with read and 2 is associated with write. So I'm going to give, if I give 6, then it becomes read write. 6 again, read write. Okay, if I do ls-l, now we have a read write permissions for other groups too, others and groups. So the number value for read write is read write is 6, right? Why is it 6? 4 plus 2, 6. 4 is read and 2 is write, 1 is execute. Read, write, execute. So these numbers, you have to remember this for rest of your life. Read is number 4, write is number 2, and execute is number 1. Okay, so the what we end up being is read write equals 6. So how will the permission show? Read write and a hyphen. That's how it will show. So the final permission, when we give here chmod 666, then it will modify the permissions here. So let's see here what else. Okay, now let's see how I did this here. Modify permissions for read write. Now what I'm going to do is let's see here. So what I'll do is so actually grant, the correct word is grant the permission, grant read write permission for all. And now what I'm going to do is let's play a game here. Grant only execute permission to group. Okay, how would I do that here? So let's look at it visually. So how would the permission would look? The permission would look this part here. Oh, by the way, I forgot to tell you guys that read is represented with an X. The execute is represented with X. Sorry about that. Execute is represented with X. You know what? Hold on. Let me. Yeah, this is W, X, W, X. Okay, so guys, if you ever run into upper cases, now uppercase is all the lowest case is just Word document is auto correcting itself. Okay, so here read is represented with lowercase r and with number 4, write 2, and then execute is this, and you get the idea here. Read, write, execute, RWX 421. Okay, so in this case here, okay, now we are good here. So for this here, the read write permission, we calculate the read write permissions here. Now what I want to do is I want to grant only the execute permissions to the group here. How would that look? Okay, so looking at here, let's copy this here. So visually, how would this look here? I want to keep the same permission for everybody except execute permission, grant not only, grant additional execute permission to group. So over here, read write so this part, is this part going to change? Anybody, is this part going to change?
Yes.
What is it going to be?
RW. Oh no, this part is not going to change. Sorry, no.
Okay, yeah, that's what I'm going to say. Okay, this part is not going
No,
to
I
change.
thought you were talking about the whole thing.
And what about this part?
Yeah, that will change.
Yeah, this will be X.
Correct.
And then this part is not going to change. Okay, so let's calculate the number associated with it. So RW hyphen is the number value is going to be, what is the number value going to be?
6.
6. Very good. RWX, the number value here is going to be
7.
7. Yes. RW hyphen, the number value is going to be over here would be what?
6.
6. Good. So now what we have to do is we have to just change the number here, 676. So what will happen is only the group will have the additional execute. So if I do ls-l, so now you see the permissions have, the group has a execute permissions here. Okay, so that is good. We did that. Okay, now what I'm gonna do is, if I want to take away the permissions for everybody, okay, what do I do? If I want to take away permissions for everybody,
Is that even possible?
yeah, it's possible.
Even from the owner?
Yes.
Okay, then it'll be all hyphens.
Yes. So if it's all hyphens, what would be the number value?
0.
Yeah, 0. Very good. All 0. So now what I'm going to say is take away all the permissions from everybody. So what I'm going to do is I'm going to do chmod and 000 and a file 1. I'll hit enter. I do ls-l. Voila. So nobody has any permission. That the file is logged out. But that doesn't mean root doesn't have permissions. Root is super user. It doesn't matter if the root has permissions or not. Still, it could go into any file if it's even owned by root or not. So root is above everything, above law. Okay, so he could do anything he wants. Okay, so good. Now so here let me just put it for copy. Uh-oh. So the permissions will be 000. So now what I'm gonna do is we have understood how to use the numbers here, right? There is another catch here. You could use the letters too. You could definitely use the letters to add and remove the permissions here, okay? Sometimes I use both ways, letters and numbers. So let's use the letters associated with the permissions and how that will work here, okay? So to the same file, what I want to do is I want to give read and write permissions to read and write permissions to only to the so I'm gonna write down here, grant read and write permission to only user, which would be which would be the owner. Okay, so how would that look? That would look like this: hyphen read write hyphen 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 1 2 3. Okay, so this is what it would look like. So what would be the number here? What would be the number permission? What is read plus write? How much? What is the number value there?
6.
6, right? And then what will be the number value for other two?
0 0.
Yeah, 600. Here the permissions is 600. We are jumping back from 00s to 600. Okay, so you got to keep that in mind. And same thing is accomplished using the letters here. How would you do that? What you have to do is so I'm gonna say U plus RW. So what is this gonna happen is U is the user. User is the owner. So if I go up here, I mentioned here that, let me get rid of this here, owner is confusing. The letter associated with the user part is U, the group part is G, and other part is O. Okay, so now I'm granting only the permissions. I'm granting the only permissions to the user. So what I'm going to do is, looking at the file here, nobody has any permissions here, so I'm going to grant only permissions to the user. Okay, it's going to be the same thing, chmod. Now what I'm going to do is U, that means user, plus RW. Whenever it says plus, means adding, and then we're going to use minus. When you do minus, it will remove the permissions. Okay, plus RW, and then the file name. I'll hit enter. If I do ls-l, see, only the user has the permissions, nobody else. Why? Because we used this method here. Okay, couple more times. So what I'm gonna do is I'm gonna give everybody the full permissions, the original permissions. Okay, grant everybody read write permissions. Okay, so if you look at it here, so I'm gonna have read write and a hyphen read write, then a hyphen read write, then a hyphen. So what is this gonna look like? What is the number value here? Simple, right? 666. And then what is this would look like? This would look like user group other plus read write. Okay, that's what it looks like. So what will happen is even though read write already has is gonna modify it. For example, if this dude has only read permission, and if you add write permission, it will add write permission here. Okay, it will do the calculation for you. So I'm gonna say chmod ugo plus read write file1, and if I do ls-l, then you get the permissions as 666. It's the same thing as 666 permissions. Now let's play this game more. So all of a sudden I found out that this the others, they don't need a write access here. It's a security violation. So what would I do? I want to remove the permission here, right? Remove permission for remove write permission. Remove write permission for others. So sticking with the formula, what would this be here? So the number value will be 6, 6. And then if I do this here, I'm removing it. So what would be now? 66 what? Read is associated, or the number associated with read is 4. So it's going to be 644. And how am I going to do this? Now you have to, what you have to do is, you have to look in carefully using here. So over here, what I'm going to do is, I'm going to do simple like this, O minus W. So for others, minus W means I am removing the write access. Okay, if you look at here previously, so let me put this on the top here. So from this original permission, what we are doing is, we are removing W here. So let me highlight W in red. So we are removing red. So this is the permission we want here. So that it looks like 644. You could definitely type 644 also. And then you could do this here using the letters chmod O hyphen W file1. And if I do ls-l, see, the permission is gone. Okay, so any other? So what I'm going to do is, I want to, most of the time I use letters to remove the permissions here, because sometimes it's easier to understand how to remove the permission here. Adding the permission, I use numbers, modifying the permissions. Because you could definitely see visually that Oh, okay. For owners, I want to remove it. For owners, I want to add it, something like that. That means that's how it works here. So if you want to do full permissions here, chmod ugo plus rwx file 1. So file 1 has full permissions here. So you guys got the idea, right? What is happening here?
Yes.
Yeah.
Okay. And if you find a file while working, and if you find a file has full permissions, stop and investigate what is going on here, why a file has full permissions here. Ideally, no file should have full permissions here. If it does, then stop there and look into see what is actually happening. Okay, let's move on to the directory permissions. So I'm going to clear out of this. What I'm going to do is I do mkdir. Okay, so I'm going to say mkdir directory 1 dir 1. Before that, let me remove the file so that I don't have any. Let me leave it there, okay? mkdir, and I'm gonna give dir1 directory 1, okay? ls-l. Now it's a different thing here. Little bit, not too much. So let's see here the default directory permissions. It's the same thing here. So the very first part here, I said D, right? If it says D, that means it's a directory. Very first D is not part of permission. It indicates it's a directory. Okay, so color up there. Okay, so these three places, read, write, execute, same thing, read, write, execute, read, write, execute, same numbers, 427, 427, 427. Okay, so but it's going to be the same thing, read, write. Read is 4, write is read equals 4, write equals 2, execute equals 1. Okay, read means read the file, write means write to the file. I'm going to copy the same thing from top here. Okay, read means read the file, read permissions, write, edit the file permissions, and for execute, so in here read the file means read the file inside it, write into the file. Here the directory write permissions is write means create new files in the directory here. Okay, it's going to be a little bit changed. Write means so this is going to change. Creating new files in the directory. Read means read the files in the directory. And execute means executing the directory is different here. Execute means going inside the directory. So by default, everybody has a read write. Execute permission is so if you look in here closely, everybody has the directory execute permissions. What does execute permissions for the directory means? That means you are able to go inside the directory. That's what the execute permission stands here. So here let's calculate what this is here. So this is read, write, execute, read and execute, read and execute here. Okay, and can somebody help me with the number here? First one is read, write, x. What would be the number?
7.
Yes, 7. And here
5.
5. Very good. And 5. Okay, 755. By default, the directories have a 755. Directories have a 755 permissions by default. Okay, so why? Let me explain the execute. If a user want to go inside the directory, like cd dir1, there is an execution of directory. Going inside a directory is considered an execution. There you go. What I did was I just executed the directory. Okay, so let me get out of there. So a regular user, or most of the time a regular user have read access to everywhere. Regular users should be able to go almost everywhere as a root user in Linux environment. Okay, once you are able to go in there, if you are able to read, write, that's a different story. But if you are able to go in there, all the directories, even I think even the regular user is able to go into the kernel directories here. So where is boot? Boot is here. So look at this here. A regular user is able to execute in there. So let's go into cd boot. Okay, so a regular user could come in and look at all these files, but he's not able to do anything to these files here. These are very important files, except the ones, whatever ones have permissions, they do. Okay, so even the graph file, a regular user is able to go in there. But once he come here, he's not able to do it. So all right, let's get back to my place here. So user is you, group, others. Okay, same thing is happening here. So the permission number for the directory is 755. Okay, so the permissions is going to work the same. So what I'm going to do is remove all access. What would be the formula? What would be the number I need to use? It's going to be chmod. What would I use the number to remove all permissions from the directory? So I have to give the number 000, all three zeros. 000 dir1. If I do ls-l, it's the same thing. Or if I do chmod ugo minus read write execute dir1, it's the same thing. It will accomplish the same result.
I have a question.
Yeah, go ahead.
So there is user, there is group, and there is others. Who are these people? So user is you, group is the group that you're part of, and then who's others?
Others, they are not part of group and they're not owners. So regular
So if a
user,
company set up, like, who will be others?
others, okay, first, so this part is So I'm gonna come to there. Um, but right here, this is what it's gonna say here. So if you go back to our yesterday's class, we have when we created the users and the groups. So the users is, if you create a user, then it has its own group name. Okay, so if you create a user here, we created a user terminator yesterday, and this will be the user ID, and at the same time system grants you the group name with your own name, user ID. So all users are part of a group themselves. Okay, they are the part of a group themselves, and at the same time they could be a part of any other group. So for the user to function inside Linux, it has to be part of some group. So by default, it cannot randomly generate or assign to any existing group here. So what the system does is, system automatically creates a group with the same name and puts you into the group. So over here, actually I should have mentioned this a little earlier here. So this part will show you the owners and the groups. It doesn't show you the others here. So others permissions are here. Okay, I'm going to explain you a little bit more. Let me finish this, then I'll come back here.
Okay.
Okay, so what is happening now is, if I do, so LSFNL, so all the permissions are gone. But regardless, root has unrestricted permissions, okay? Okay, now what I'm gonna do here is, so actually this directory, let me create another directory here, mkdir/user. So I'm creating this directory in the slash directory, root directory. Okay, if you do lsf and ld user dir, everybody has the permissions to go inside this directory here. So if I go into another session, so in here I'm logged in as a user terminator here, right? If I'm a user terminator, if I want to go into slash user directory, looking at here at the permissions, the directory permissions is, this is the owner and this is the group. We don't get to see the permissions for the we don't get to see the permissions for the others. All you have to do is, you will get to see the permissions over here. in this place here. So let me copy this here. Okay, so over here, if you're looking at the permissions, you can only see the users and groups. Others are not listed. Okay, so this part is a group, this part is a user. Okay, yellow is a user and orange is a group. So over here the root is also a group here. Okay, users yellow and others, I'm sorry, groups is orange. Okay, so this is the informational here. Okay, so let's move forward here. So now what is happening here is, looking at this directory here, if I want to go in this directory, and the permissions for this here is other. So in this scenario, it has to be part of root or other here, but we have others as execute permission here. So a terminator at this moment, he's other. So let's see if he's able to go in there. So yes, as a regular user, he's able to go in there, and there is nothing in that directory here. Now what I'm going to do is I'm going to take away the permissions for this directory. I'm going to do chmod 000 and hit enter. If I do ls-l d user directory, see the permissions are gone. So let me exit out of here. Exit, I was supposed to get out of the so I'm going to log in as terminator. Okay, now if I do ls-ld user data, user drive, there is no permissions for terminator to go in there. So if I do cd user dir, so there is no, he's denied the permissions. In the Linux environment, almost everybody have permissions to at least go into the directory. Okay, but if you deny the permissions, then he cannot go in there. So over here, let's work with this directory here. Remove all access to. So we are working with this directory, right? So the reason I am working with the outside directory from the root directory is so that I could show you this. And what was the permission for the user directory? Okay, I'm gonna get rid of this, and I did this here. So this part, remove all access to the directory here, right? And this part here is that, and then I remove the access here. So now I am going in there as a user terminator, and he's not able to get in there. Access denied. Okay. So now what I'm going to do is I'm going to give the execute permission only to others so that other people could get in there. So how am I going to do that? Same thing, right? chmod o plus x user data. Okay, if I do lsf and ld, so you see execute permissions here. Grant execute permission only to others. So what I'm doing here is not important here. What I'm showing you is the important thing here is how you are manipulating and changing the permissions here. So if I go in there, cd, try to go in the directory. Now I'm able to go in the directory now. Okay. Permissions work instantly. It doesn't have to wait for any server update, anything like that. It is instant. Okay, so Terminator is able to get in there now. Okay, so you get the idea here, right? If it would have been, what would have been the number? If you want to give only the permission only for drive here, what would have been the number? So the number, how would it look like? This is how it look like, right? So what is the number permission here? Anybody?
1.
1?
Yeah.
Okay. And there would be O plus X. So, but actually the number position would be like this here, 0, 0, 1. Okay, if it's just a 1, I don't even know if I just do 1, what will happen here. It will probably give it to here. I failed to mention that it has to be a 3-digit number. Now is the time to, I think you guys got it already here now that we went into an error. So modify permissions here. So if you're using numbers, you have to give the 3-digit number. So where should I put this here? Modify permission. Okay, here is the good place to give. If you are modifying permissions using number, it must be 3-digit. Okay, is that good explanation here? Or so if you do 001, let me go ahead and remove the permission here. If I want to just remove it, just X hyphen, and if I do ls-ld user data. Okay, so if I want to do chmod 001 user drive, and if I do ls-ld user data, there you go. That's how it works. So over here, so this is how it's gonna work here. What I'm gonna do is, I think I have a list of all the permissions, how it works. At the end, I'll put in a bunch of permission numbers and associated with it, but I'm not done with this yet. Let's go ahead and take our good 15-minute break here, and we'll reconvene, and then we'll finish it off. We still have another hour and a half. All right, so break starts now. Are you there, Burhan? In class.
Where's Mama's coconut? I'm going to break it.
Mama's coconut?
Yeah.
It's not here.
Oh, and
Close the door. Yeah, do that. Slam it. Okay, so now what we have here is, so the regular user is able to go in there because it has a execute permissions here, right? Okay, so good. Now let's try something else now. I'll talk about UMask. Okay, there is a feature built in. It's called UMask. UMask. So what is this here is the permissions are given to the system. Permissions are based on the default UMask. Okay, so we'll talk about that now. So I said a little bit earlier that the system default for the file and folder is coming to be, for the files is 644, and for the directories is coming to 755. Right? Where is that number coming? Where is that permissions coming from? Okay, so let me clear the screen. So if I do ls-l, or let me go ahead and remove this asterisk. So what I'm going to do is mkdir dir1, or let's do dir2 touch file2, so that you don't get confused. If I do ls-l, so these are the default permissions that are showing up in here. All right, so So where are these default permissions coming from? So for the files, the default permission is 644 and 755 for the directories here. Seven 55 is the default directory permission. Okay, and six 4 is the default file permission. Okay, so where is this coming from? So all this is coming from the default umask. So I clear the screen, and if I type umask and hit enter, what will happen is it will give you a number here. 4-digit number here. So let's focus on this number here, and I'll explain you what it means for the system here. So by default, system provides 644, right? 644 permission to file by default system 755 to folder, okay, directory. So let's see here what is this 4-digit number means. Okay, so 4-digit number is so what I'm gonna do is let me just put this together here. And so I'm going to put 0 in here, 0, 2, 2. Okay, so the first part, 4-digit first part is symbolic here, it's not being used. SYMBOLIC, okay? And then the second part here is also, I'm sorry, the second one is used for users. And the third part is used for group. And the fourth part is used for others. So mask means, what is mask? Mask, the English term for mask is stopping it, right? Stopping that permission from being granted. So what is happening here is, let's talk about the file permission. In reality, the file permission is based out of 666. Are based on the permission 666. So what is happening here is, if I may have okay, so let me have this here. So I have here is users. What the system try to do is it will try to give everybody 666 permission. Okay, and if the UMask is not present there, if the UMask is all 000, what would be the permission would be? It would be 666. Okay, system provided permission okay, and then the UMask, what it does is it removes the permission. Okay, so what is the UMask set to? It's set to 000, right? So, but we are worried about the only this here. So 0, 2, 2. So the UMask is set to 0 to 2. I'm just not showing you the leading 0 here. And then the final default permissions. So what would be in here? 6 minus 0 would be 6. 6 minus 2 would be 4. And 6 minus 2 would be 4. So the final default permission is 644. So if you look at it here, if you look at the default permission here, 644. Why is it doing that? Because the UMask is set to 0 to 2. Okay, don't worry about the leading 0 here. It's undefined. It's just symbolic. But the system is looking into this last 3 digits here. Okay, can I proceed? Is that clear enough?
Yes.
Yeah.
Okay. Now, in future, we could change the permissions to the default UMask. So now, what I'm going to do is I'm going to say directory and the directory permission is directory permission based on 777. Okay, by default, if the permission is being granted here, what is happening here is the system want to give the permission which is 777. 777, and then the final would be 777. But default, but what is happening here is since it's submitted, so the UMask is set to 0 to 2. It's removing the permission and making it 7 minus 2 would be 5. 7 minus 2 would be 5, and then the final permission would be 755. And over here is going to be 7. So if you look at it here, if you just eyeball it here, this is 7. And then the middle part is 5, 5. So that's how the UMask is set to. We could definitely change the UMask here, but it's not recommended. But we will change the UMask and see how the permissions are working here. So let's see here. So what I'm going to do is I'm going to set the permissions to so let's set umask to all zeros. Okay, and we'll see how this is going to play out here. So what I'm going to do is I'm going to set umask to all zeros here. It's a simple command, umask 0000, and hit enter, and you type umask, and it is set as all zeros here. Okay, since umask is set to all zeros here, so what I'm going to do is, and here's a note here, note, system goes back to default when the system reboots. System goes back to default umask when the system reboots. Okay, I'll show you where to make it permanent if you need to, but most of the time you never worry about umask. So let's see here. So if I do touch file 1 or file 3, okay, what would be the umask will be here. So if this is 0 and 0, so what will be the umask here? What is the umask I'm expecting here? It's 666. Very good. And you see the umask for file 3 is 666. Okay. And if I do touch file mkdir dir3, what should be the permissions I should expect?
777.
777. Very good. The permissions for the directory is 777. Okay, so when you are working through this, and if you find odd permissions here, stop there and take a hard look. Okay. Okay, so let me just remove this here. So this is what it's based on. Okay, so you get a 666 permission and 777 permissions. Why? Because our good old umask is not doing anything. It is set to all zeros. So now permission is 777. Permission is 666. Okay. Now, okay, that's about it. Now let's move to the group permissions. Okay, so it's getting complex here. What we started from simply creating a user, now we are way deep into these permissions here. So yesterday we talked about groups. So let me clear this. And here, group permission. So how does the groups work in so in Linux groups, Linux groups is a mechanism to manage a large collection of users and permissions and manage their okay. All Linux users have a user ID, and group ID. Okay, so by default, okay, group ID is okay, so the Linux user groups is a mechanism to manage a large collection of users and their permissions. All Linux users have a user ID as well as at least as well as group ID by default. Okay, so what is happening here is by default the group ID is there here. So let me do Linux users group ID. So group UID is a UID. Okay, the short is used all the time here in the jargon is UID, and then the for this one here is GID, 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 GID. So if your coworker says what is the UID and GID, that's what they're referring to as. Okay, so let's see here. What I'm going to do now is permissions. So here yesterday I showed you, if you go into VI etc. Okay, let's talk about the group here. ID terminator. Okay, so yesterday he is so ID terminator, when we created the user, so the system took a liberty to create the name. We used the name to create it, but it did assign the user ID. Okay, at the same time, a user cannot be orphan, it need to be part of a group. So what system does is it automatically creates a group with the same ID and the same name, and it puts that user into that group here. So that becomes the default group. And then the groups, here is the information here that the user belongs to, how many groups the user belong to. A user could belong to many groups, okay? So in this case, the user belongs to the group name Terminator, which is
We
a
are a
default.
group. We are a family.
I'm sorry? And then since we fooled around with the user Terminator yesterday, grant him the root access, he's part of a wheel group also. Okay, so if we go back up here, so the permissions and user administration is interdependent on each other. So in this case, he's part of two groups now. Group the user is part of. Okay, he's a part of these two groups here. Now what I'm going to do is, so this was created here. So now what I'm going to do is I'm going to manually create a group. So this time this is a new command, group add -g. Okay, that means group add means group name, and then I'm going to give the number here. By default, so yesterday I showed you where is the default IDs being assigned here. If you go into info.conf file, that is where the default ID is coming from. Okay, so if you do vi etc login definitions, this is where the definitions are defined here. It is automatic unless you are assigning it manually here. So what I'm going to do is I'm going to assign the group ID manually here. So I'm doing group add -g, and then I'm picking up the group ID number. I'm doing 9000, and then I'm going to create a group name machine. Okay, so what I'm going to do now is, if I go into grep/etc/ group file, this is where the, in fact, let me go in there actually, so that if I go all the way down here, the newly created group is created over here. Okay, and nobody is part of that group here yet. Okay, look at the wheel group here. So start of this part here is wheel group, and it tells you that the terminator is part of that group. Okay, and if you go down here, machine is just a group here, and nobody is part of that group yet. I'm going to quit. Now what I'm going to do is I'm going to put terminator into the machine group. Okay, how do I do that? I'm going to put him into the machine group. I'm going to call user add user mod -a, and if I do capital G, that means it becomes a secondary group. Okay, and then I'm going to give him the machine name. Either I could do group name machine or 9000, and then I'm going to put him in the group. In fact, before that, let me copy this part here. So create a new group. So I'm going to split this up so that you could know what this is. One, two, three, four. Okay, so we have 4 here. The first is group add is just the command. Okay, -g, that means it's you're adding it a group here, and then 9000 is the number, group number, and the name, machine name. Everybody has a name and phone number, right? That's what this is. Okay, so this is just nothing but a command. This means lowercase g means a primary group. And 9000 is a gid, GID, and this is a group name, UID. Group ID and group name. Okay, so similarly, we put this guy in the group name machine because he's from future. Add user to the group. So if I look at this command here, if I copy, similar thing is here. So in here, what is you doing? You're adding, and then A stands for -A stands for add. Okay, and lowercase g stands for secondary group. Okay, or I think it's uppercase, right? Upper G, so it's a secondary group. And then the machine, so either GID or GID or name would work. Okay, and then over here also either UID or name would work, and then we give the name here Terminator. Okay, so now if I do if I hit enter and if I do ID Terminator, voila, he is part of 3 groups now. Okay, so now looking at it here, this is his group ID, user ID, this is his group ID, primary group ID. Okay, and these are the other groups he belonged to. It's going to show you the primary groups also, and these are all his other secondary groups. So here okay, is this good enough explanation? Is it driving home, right? Good. So now let's see how these things are going to work here. So I'm going to create a folder and give the permission okay, so so I'm going to clear this. I'm going to so assign the permissions, right, based on assign folder permissions. So let me create a folder mkdir slash I'm going to give him the assignment. So his assignment is to go terminate somebody. So he need to go into that folder and then see who he need to terminate. Okay, so in there he got permissions here. Now what you have to do is you have to do a ls-ld assignment. Okay, so the permissions here is, I don't want to do that. Let me go ahead and put my umask back. Umask is 0022, okay? So that looks much better. So now what I'm going to do is I did this here, and now as a terminator should be able to go in there. Okay, cd/assignment. If I do ls-l, so he's able to do this here. But let's see if a terminator is able to create a file here. So if I do touch file 1 as terminator in that place, it says he doesn't have permissions here. Okay, so what I'm gonna do is, instead of giving an individual permission, what I'll do is I'll give the group the permissions here to do it. So how do I do that? How do I change the permission here? So this is a new command I'm going to show you. So here, so this is a create folder. And here I'm going to say terminator is unable to create file 1, okay, in /assignment. Okay, so now what I'm gonna do is so I'm gonna assign change the group ownership. Change the group ownership to machine. So I have it here, right? So if you look at it here, the group ownership here is, if you look at the group ownership here, it is owned by it is owned by root here. So what we're going to do is we're going to change the ownership here. So what I'm going to do is I'm going to change group chgrp, okay, 9000, and then I'm going to change the assignment. And if I do ls-ld assignment, so now you take a look here, it's been root changed from machine, it's been changed from root to machine. Okay, and then we're going to change the permissions also for this assignment here. So if you still see here, he's not able to create the files here because he doesn't have a write permissions here. So we need to give the write permissions here. chmod 775 assignment. If you do ls-ld assignment, now you see this part here, group part has a write permissions also. It's kind of crowded here to look into it, but you'll get used to it. So what I'll do is let me remove this part here. This is nothing. And here I'm going to highlight machine is the group owner, and I'm going to highlight this part here, read, write, execute. Machine is the group owner of the assignment. So now over here, and a machine group has read, write, execute permissions. Okay, so now let's go ahead and go in here. Let me get out of this and let me go back in there. And if I do touch file 1, permission is denied. Why is the permission denied? cd dot. Let me re-log in here. Maybe I need to re-log in. Terminator. Let me go into assignment. I'm going to say touch file 1. Okay, now he's able to do that, and and now you see this is being, now he went in there and he's able to create the files in there. Okay, even though we have not given him the single permissions for him to as a specific user, we gave the permission to the group. So since he's a part of a group, then he's able to execute the commands, or whatever the permissions is he has. Based on that, he will have executed those permissions. Okay, is that clear enough so far? Am I going too fast? Let me know if I'm going too fast. I could slow down a little bit. Okay, so I'll go in the same speed. So we change the permissions here, change the group ownership, and the permissions.
If you go
Also,
back
yeah, go ahead.
one, you change the permissions.
I'm
How
sorry,
you
one more
change-
time. Hello? What was the question?
I wanted just to see the putty really quick, what you did there.
Oh, this? Remember, group
Change it.
the directory permissions are more regular. So what happens here is, then again, if you go in here, let me close this. Okay, yeah, go ahead.
So which changed the group ownership to machine?
This command here, because we use, either you could use the name or the number here. So I think I should put that in there. Chmod. So this part here, I'm gonna split this. How many I got? 1, 2, 3.
So why does 9,000 change the ownership?
Because 9,000 is a machine number. It's a group ID. Okay, so if we look at if you look at ID terminator, if you look at group 9,000 or group ID, ID group. No, it's not correct. But anyway, so ID terminator. Remember, we assigned the machine name 9,000 here. I told you if we didn't manually assign it, it will able pick up from what the default is set to. So over here, when we created the group here, we purposely assigned the machine name 9,000 over here. Over here. Is that what your question is? Your question about where the 9,000 is coming from?
Yeah, that was my question, where it was coming from. So
Yeah. I manually assigned number 9,000 just to tell you that you don't have to use the default. If it would have been a default, whatever the default is set in, I think we set it to 3,000s. If I don't give the default here, it will automatically pick up the 3 default, whatever is set into the info config file.
okay. You can't have two different groups with the same group ID, right?
No,
Okay.
that's not allowed. Now number 9,000 is reserved for the machine ID machine unless you delete that group.
Okay.
Yeah,
The same thing goes for the user IDs, right?
true. User ID is true. Okay, so let's see here what else. Now there is one more way to change the group is let me just make this look as good here. Oops, not that one. Add user to the group. Okay, so this is what we did here. And okay, so change group is 1 2 3. Change group is 3. So here CHGRP 9000 machine. Okay, so this is just the what will happen is this would be the command, and this is the grid ID, and this is the folder. Okay, so I'm going to delete this here. So there is one other way you could use is there is a chown command. Okay, so there is one other way you could change the ownership of the group is you run the command chown. Chown means group ID. So if you do ls-ld and assignment, so what I'm going to do is I'm going to make the terminator the owner now and the machine the group. Okay, so if I do chown, I'm going to say terminator and machine is the group, and then I'm changing it to assignment. So if I do ls-ld assignment, you see now the terminator is the owner and then the group is the machine. So if you do go assignment here, and if you do ls-ld, now the file name has also is be owned by no ls-l actually. Okay, the file name is terminator here, right? Now what I'm gonna do is I could do the recursively. If I do chown uppercase -r, so what will happen here is even the file name is going to be will be changed to the machine name here. See, look at it here. The file name up here was owned by terminator here, this line here. Owner was terminator and group, primary group of this file was terminator 2. Now going forward, this is going to be the terminator and the owner would be the machine. Okay, so the group owner would be the machine here. So if I create another file as a terminator here, touch file 2, and if I do ls-l, now okay, so I need to change the faculties here. That would fall into a different no, I have to get out of here and go back in there. Let me see, touch file 3. Still not doing it, huh? Maybe I have to exit out of completely. Let me go back in there again. Okay, now I'm going to do touch file 4. So the terminator, okay, that would be in grid when I explain you the sticky bit. Okay, so I got confused here. So far we'll just keep it the same here. Don't worry about what just happened. File 3, file 4, okay. So I'm gonna say the change
So what does the -R stand for?
yeah, actually wait up for that. I don't want to talk about that now, because when we are gonna do the directory permissions, then we'll do more. I'll tell you here, hyphen uppercase hyphen R means recursively. Change the permissions for the existing and no, change the permission going forward as well as permissions for the existing files. So
And you did CH when you set terminator to be the file owner and machine to be the group owner, correct?
yeah.
Okay.
So I'm gonna put this here. I'll come back to this here because I told you the permissions and owner administration, user administration are interdependent. So let me put this here using the chown command. Okay, this is the same thing here as this one here. Okay, this is the same thing as this here, but no, actually this is the same thing as this here. Let me clear this. CD, I'm gonna say chown and then a colon machine and assignment. Okay, ls7ld. Nothing has changed since we already assigned it. So either you could use the change ownership. If it's blank here, it will keep the existing ownership, okay? And then it will change whatever in here. And if you're just changing this here, the user, then you have to use just like this here. No, actually don't. I'm confusing here, but let me just leave it like this here. Then we'll come back there. Okay. So what will happen here is this is another way of changing ownership. Okay.
So right now this will change group ownership, right?
Yeah.
Okay.
Okay, so this command change group or change owner is the same way you do it here, okay? Over here you could also definitely put 9,000 in there. It would be the same exact thing. There's all
So if you were trying to change the owner of the file, you would just flip it around?
yes. Exactly. Because
So the colon?
when you assign the colon here, that means you are providing this space here. You are directing it. So if you put the colon here, that means you are telling the system to assign the group here. But if you put like terminator and colon, that means you're telling the ownership. The user changed the user part, and like this here changes the group part. I will explain you because this part is gonna get expanded, and I don't want to confuse you here because in permissions there are multiple ways to do same exact thing, and I think there's still a lot to cover here. Set GID and sticky bit here. What is the time here? Okay. You know what, actually I'll stop it here and we'll pick it up next week from where we left off. And yeah, we still have a lot of things to come in here. After this administration, I'm going to start scripting. Then we'll go into Ansible. Do you have any experience with Ansible?
No.
So let me see what else. There's a lot of things coming here. So this is my previous class here. So we completed disk and on this SSH, and then we have to do SCP, BSTP, Kickstart, Samba. There's a lot of stuff still coming in, and so once we're done with the user administration and permissions, a good chunk has been done here. Then we'll focus on scripting. Scripting is major. Scripting will take good amount of time, and Ansible. Then after that, then I'll start setting up the services, the DNS. We'll set up DNS first. After that, we'll set up other stuff. Kickstart is there too. All right, not to worry. We have a lot of time to spend together, so there are a lot of things coming in. But I mean, all these things. User administration is very important because you will have root access and you have to do all that. And on the production boxes, you have to do any changes under change management. And for non-production boxes, all you need is approval or email, and everybody should be copied on it, your team and all that. That way everybody knows what is going on. And if you make a mistake here in Linux here, just own it up to it, and you say you made a mistake. Don't try to hide because everything is logged and tracked. So even now, we have so many people. Some of the people I'm working with, they are working in Linux for 20 years, but they still talk in the team meeting before doing any changes. So those are the things you need to remember. But I'm sure you're not gonna go in there and gonna go guns blazing. But this is a very good skill for you to have it here. And this will put you actually in a 6-figure salary, believe me. So, and there is a Facebook data center coming up in DeKalb. So I'm hoping, by the time you guys graduate, done with this class, you'll be ready for, hopefully those jobs will open up there and then you could start working. Because any big corporation, they are highly, highly dependent on Linux here. Even if you go into AWS, most of the servers inside AWS is running Linux. All right, I'm gonna end here, and then we'll continue working on permissions next week, and after that, we'll see how things are gonna go.
Okay.
All right, guys, you have a good weekend, and put in the chat if you have any questions. I will try to answer it right away.
Okay.